In this lesson, we're going to take a look at balancing chemical reactions. And the reason we balance chemical reactions is because mass is conserved. That means we always have to start and end with the same amount of stuff, and we need to show that in our reaction because sometimes the ratios of things change because the charges are changing in an ionic compound or the molecules are changing in a molecular compound. So we have to use these things called coefficients to balance chemical reactions. Now, this is not hard, but it does take a little bit of time. So I think the easiest thing to do is show you a simple reaction that we can balance, and then we'll move on from there. So a nice easy reaction is actually one I showed you earlier, the reaction of magnesium metal with hydrochloric acid, HCl. Okay, this produces magnesium chloride, MgCl2, and hydrogen gas, H2. And the reason H2 is not just H, but H2 is because it is a member of the diatomic family Brinkelhoff. Okay? So, this is a single replacement reaction. Magnesium replaces hydrogen. And the reason these formulas are like this, right? Magnesium is just a metal, so it's like that. Why is hydrochloric acid HCl? Well, hydrogen has 1 valence electron. Chlorine has 7 valence electrons. When they bond, they share that pair. It's HCl. Magnesium, though, over here, this becomes ionic. Magnesium has 2 valence electrons. It gives them both away and becomes magnesium 2+. Chlorine has 7 valence electrons. It takes in 1 and becomes chlorine 1-. That means we have to have 2 chlorines to balance the charge of 1 magnesium ion. So this is my reaction, and it's right in terms of the formulas, but it's wrong in terms of how much of stuff is there. Because if you look, there is 2 chlorine atoms over here, 2 chlorine ions, and 2 hydrogen atoms right here. So I'm ending with 2 chlorines and 2 hydrogens, but I'm starting with only 1 of each, and that's not allowed because I cannot create these 2 atoms out of thin air. And so instead, what I do to remedy that is I say, well, if I ended with 2 things over here, I'm going to start with those 2 things over here. But I can't just willy-nilly change these subscripts because that actually changes this compound, and I can't change the compound. What I can do is I can change the amount of the compound. So I'm going to put a 2 in front of it, and this says instead of magnesium reacting with 1 molecule of hydrochloric acid, it's going to react with 2. This term is called a coefficient, and it multiplies everything in the following formula, in the following compound. So this says this is not just HCl, it's 2 HCl's. And now I actually have 2 atoms of hydrogen and 2 atoms of chlorine, so that when I end, I can have 2 atoms of chlorine and 2 atoms of hydrogen. This is now a balanced reaction. If there are no numbers in front of it, it's understood to be 1. So you can actually read this reaction as 1 atom of magnesium reacts with 2 molecules of hydrochloric acid to produce 1 unit of magnesium chloride and 1 molecule of hydrogen gas. So it's actually counting atoms. This is really telling me how many atoms or ions are present in this reaction. So that's a nice simple one. Let's look at one that's maybe a little bit more complex and see what we're going to do. So I showed you guys this reaction in class one day. I took sodium iodide and I reacted it with lead nitrate, lead 2 nitrate, PbNO3 2, and we got out of that sodium nitrate, which is NaNO3, and lead iodide, which is PbI2. Now don't let it scare you that this is a giant long molecule or that we have this polyatomic ion in it. Remember, we treat polyatomic ions like they're one thing. So since NO3 is on this side of the reaction, NO3 is also on this side of the reaction. I'm going to put that in parentheses just so I remember that. Now, there are a couple rules to follow when you're balancing reaction. Rule number 1, start with the most complex compound. Okay. Rule number 2, never, ever, 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 never change subscripts. You can't do that. That changes the compound. Rule number 3, check work. Okay. Always go back through at the end and make sure what you're doing makes sense. So, the most complex thing is a judgment call on your part, but I would say it's either this one or this one because they have lots of subscripts and things going on in it, and because there's two of these as opposed to one of them, I'm going to start right here. I say that's the most complex thing. So if I look at that, that shows me that there are two nitrate ions on the as reactants. That means as products I need two nitrate ions. I don't have them, so I have to multiply this thing by 2, right? That's understood to be a 1 if there's no subscript there. So I'm going to multiply this whole compound by 2, and now I'm going to work my way back through what changes that caused. Okay, so I multiplied this compound by 2, and that multiplies everything. So now I have 2 nitrates, which balances that, but it also gave me 2 sodium ions, and the sodium means I need, if I'm ending with 2 sodium ions, I need to start with 2 sodium ions. But if we come over here, I can only see 1, so I'm also going to have to multiply this compound by 2, and so that gives me 2 sodium ions, but it also gives me 2 iodine ions. So now I have to go make sure my iodines, but there are already 2 of them there, so there's only 2 iodines, and that balances my 2 iodines. And then the last thing to check is lead, Pb and Pb. There's only 1 of each, so they balance. Okay, so I started with most complex. I didn't change subscripts. I used coefficients. Okay, and then I'm going to check my work. So I'm just going to begin at the beginning and work my way through. Now, this says 2 sodiums, 2 sodiums. Cool. This says 2 iodines because there's 2 here, and so 2 iodines, so that's good. So I'm going to go ahead and be like, okay, got this one taken care of. Now I can move on. Lead, there's 1 lead atom here, 1 lead atom here, so we've got that taken care of. 2 nitrates, 2 nitrates, got those taken care of. So I have just as many things that I'm ending with as I started with. Okay, so that's what you're doing when you're balancing a reaction. One more example, we'll look at a combustion reaction. Okay, we'll look at the combustion of propane. Propane is C3H8. It's going to react with oxygen, O2, to produce CO2, carbon dioxide, and water, H2O. Now, the rule says let's start most complex. Well, this to me is most complex because it's got the most stuff in it. So I'm going to start there. It says 3 carbon atoms. So I come to my product side and I only see 1. There's 2 oxygen atoms in this compound, but only 3 carbon, or only 1 carbon. So I have to multiply it by 3 to make my 3 carbons match. Now, I'm going to go ahead and look at my hydrogen here as well, and I see there's 8 hydrogen atoms here, but only 2 over here. That means I'm going to multiply this thing by 4, so now I have 8 hydrogens on the right, 8 hydrogens on the left. The last thing to balance is oxygen. Now we have to be very, very, very careful. I'm starting over here with 2 oxygen atoms, but over here oxygen appears in 2 places. Okay, oxygen appears here in CO2 and here in H2O. And it's easy to look at this and go, oh, there's 2 oxygen atoms here, but there's not. We put this 3 in front and it multiplies it. That means there's 6 oxygen atoms here plus however many oxygen atoms are in this compound. And since this is a 1, 4 times 1 is 4, there's 4 oxygen atoms here, which is a total of 10 oxygen atoms, which means I need to start with 10 oxygen atoms, which means this has to be multiplied by 5. Okay? So 1 molecule of propane will react with 5 molecules of oxygen to produce 3 molecules of carbon dioxide and 4 molecules of water. So when you have two or the same element appearing in 2 different compounds, sometimes that can be tricky. Just keep track of it. It's not too bad.